Okay, so I've started the recording, and after the class, it may take around 1 hour for this video to be available. Okay, I will share the link to this on your Teams. Okay, I hope everyone knows how to access. Yeah, I hope everyone knows how to access your Teams. So you need to go to the Teams, and in your this one, in your team, either in the general tab, this will be getting available. Okay, or else I'll. Do you have a WhatsApp group for everyone?
Yes, sir, we have.
Yes, sir.
Yes, sir.
Yes, sir. So one of you need to add me to that group, and I will share the link to this recording on that video. Okay. Fine.
Okay.
So
Okay,
now let me walk you through the complete syllabus one by one. Okay. In between, if you have any doubts, you can just raise your hand, or it's actually difficult. Fine. Let me see. Fine. Okay. So 4 members have still raised their hands. I request them to lower them. Vinay. Okay, good. Vinay, are you there? Are you hearing me? Lower your hand. Fine, good. So if you get any doubts in the middle, anytime, just raise your hand and I will stop to clear your doubts. Fine. So the first topic that we are going to do will be scales. Now scales, when we see scales, we generally mean this scale, isn't it? We all know about this scale. It's a ruler which is used to mark the lengths, correct? But when we talk about scales in engineering graphics, we mean much more than just a device used for drawing the lengths. So this is a device used for drawing the length, and the scale used here is 1:1. 1:1 means if I draw a length of, let us say, 4, if I draw a length of 4 centimeters, the actual length of that will also be 4 centimeters. So let me just show you. The actual length of that will also be 40. Actually, it's 4 centimeters. All the dimensions will be shown in millimeters, and that's why it is showing us 40. Okay. So when I draw 4 centimeters, the actual length will also be 4 centimeters. But many times, what happens in engineering graphics, we come across diagrams that we cannot draw on the sheet. Again, for example, you want to draw the plan of the building. The building size will be very, very large. It cannot fit on your drawing sheet, correct? And many of the mechanical machines also, they'll be very big in size. So we cannot fit those machines, diagrams of those machines cannot be fit onto the drawing sheet. And in such cases, we have to reduce the size of the drawing. Fine. So we have to use scale like 1:2. Yes, Vinay, you have a doubt? Unmute yourself and ask. Fine, I'll continue with it. So, okay, so lower your hand. I see that your hand is raised. That's why I ask you. Okay, fine. So, yeah, so we have to reduce the scale. So we can make it half, or we can make it 1/10, we can make it 1/5. There are a lot of different scales available to us. Fine. So in engineering graphics, when we say scales, we mean what is the ratio that we are using. Okay? Either are we making it half, are we making it 1/10, are we making it 1/100th? Sometimes we may also have to use very, very big scales, like 1:1 lakh. So 1 lakh times we have to reduce it. Fine. So suppose you want to draw diagrams that for which the length is in kilometers. Yes, Javed, you have any doubt?
Sir, can you zoom the screen little bit?
Sorry?
Can you zoom the screen little bit, sir?
You want me to zoom the screen? Okay.
Yes.
So is it not visible? Don't worry about this particular problem right now. I have not told you how to solve this problem. I'm just discussing what is a scale. Okay. So just concentrate on this particular thing. We will learn how to solve it, what is the question, how to solve everything. We will learn later. Fine. Okay. So don't worry about the contents. Just listen to what I'm talking about. Okay. So, fine. So lower your hand. So that's what is scale. Fine. So we'll have to use different scales for different diagrams. And once we draw the diagram, later on, if some engineer wants to measure something on your diagram that you have drawn, then he cannot use this scale, right? He cannot use this scale. Can he use this scale? No, because the actual length will be different from the length that is shown in the diagram. So in such cases, the engineers have to draw such scales on their diagram itself. Fine. So they have to draw these scales on their diagrams itself, so that with compass, if someone wants to measure any length on the diagram with compass, so I don't have a compass in AutoCAD, so I will use circle whenever I have to use, whenever I need a compass. Okay? So whenever, suppose 1 meter is the length here, right? Or else let me just randomly draw a length here. Fine. So I've randomly drawn this length. I don't know what is the length of that. Now suppose you want to measure this length using this scale. Then you have to take the compass, keep its one end here, the other end here. Now this radius of this circle is equal to the length that we want to measure, correct? So this scale, we have to keep it here. And now you can see what is the length. Fine. So can you tell me what is the length? 0 to 1 is exactly 1 meters. 0 to 1 is exactly 1 meters. And on the back side, yeah, on the back side you can see we have subdivided this 1 meter into how many parts? 10 parts. We have subdivided 1 meter into 10 parts. So what is the distance between any two lines? Sorry. What is the distance between any two lines?
1 centimeter.
0.1 meters.
10
1 by 10.
centimeters.
It will be 1 by 10, right? 1 by 10 means 0.1 meters. So what is this length that we have measured right now? So 0 to 1 is 1 meter plus how many divisions? 9 divisions. 9 divisions.
0.2.
Yeah. So it will be 1.9
1.9.
meters. Rounded off. Okay. So exactly speaking, it's falling short of a little. So rounded off, when you round it off, it is 1.9 meters. Someone has unmuted yourself, please mute. There is some traffic sound coming. Okay, thank you. Okay, so I hope that is clear how to make the measurements. Okay. So now this scale that you see on the screen is a simple plane scale. This is a plane scale. So plane scale has main divisions and one main division is subdivided into smaller divisions. Okay. This is called a plane scale. Now the minimum distance, how much minimum distance you can measure on this scale? 0.1 meters, correct? So minimum distance that we can measure on this is 0.1 meters. What if you want to measure 0.01 meters? Can you make on this? Can you measure on this? Like in this circle, you can see this is not meeting exactly. So we are rounding it off. We have rounded it off to the nearest value and we are telling it's 1.9 meters. But what if you want to measure this more exactly, more precisely? Then we cannot use the plane scale. In such cases, we have to use this type of scale. Fine. Now this scale is called a diagonal scale. What is it called? A diagonal scale. Now diagonal scale allows us more precision. Fine. So let us take the same length and let us try to measure it using the diagonal scale. Okay. So when you want to measure using diagonal scale, you have to keep the scale like this. Then from here, you have to go straight up. And you have to check which one it's matching exactly. So it's matching here. So it's matching here, right? So we have to measure distance from this point to this line. So how much is that? So this is 1, 0 to 1 exactly is 1. And then from 0 backwards up to this line is 0.8. Okay, are you getting? Let me just show it here. So 1 meter on the main scale plus 0.8 meters when we go back. Then on this line we have to go up. Now how many lines we are going up? We have to count that. So 1, 2, 3, 4, 5, 6, 7. Okay, so 7 divisions we are going up. So each of these divisions is 0.01. Is 0.01. So how many divisions we went? We went 7 divisions. So 0.01 into 7 is 0.07 meters. Okay, so this is our length. This is our length. So how much is the length? 1.8.
1.87.
Very good. 1.87. So we found that diagonal scales measure more precisely. Okay, more accurately they measure. There is some disturbance coming. Please mute yourself. Okay, fine. So this is the diagonal scale. Now there is some disadvantage with this diagonal scale. Yes, Vishal, you have any question?
Yes. Sir,
Yes,
in
ma'am.
the diagonal scale, when we go from bottom to upside, you said that it will intersect at a point. The line will intersect at a point. Now, star is given up. But what if it does not intersect at any point?
Then again we have to take the rounded off value we have to take. Like in previous case also
Rounded up.
plane scale. In plane scale also it was not meeting with any of them correctly. है ना? So what we did, we took the rounded off value. So same way here also. Here also if you watch carefully, it's not meeting. It's meeting somewhere here. It's meeting somewhere here. So what I did, I took the nearest value. I can go either go up or down because it is equidistant from both. Okay? So I have taken the bottom point. No problem. That much, error is acceptable. That much error is acceptable. You cannot do anything about it. Okay? So this is the diagonal scale. Next, we have something called a Vernier scale. Okay. So this scale here is a Vernier scale.
Can you repeat diagonal scale?
So there is a big advantage with Vernier scale. It takes up much lesser space compared to the diagonal. The diagonal scale, you can see it's so thick, है ना? It's so thick and there are so many lines in this. Whereas Vernier scale, you can see it's very thin. It is taking up as much space as the plane scale itself. But it can measure as accurately as the diagonal scale. Okay? If you have any questions about the theory, how it is happening and all, I will explain to you when we are discussing about Vernier scale or plane scale in detail. Okay? So right now, my aim is just to show you what all is there in the syllabus. Okay? So don't worry about the details. We will take up the details as and when we are covering the topics. So Jayant, any doubts? Jayant?
Once again, diagonal.
Yeah, the recording of this is it is getting recorded anyway. So you can watch the recording if you want me to repeat, okay? Because yes,
Okay, sir.
okay. Sai Teja,
Sir, I have a doubt in diagonal scale, sir.
yes. Tell me, ma'am.
Sir, in diagonal scale, we have taken the point measuring from 1 meter, sir.
Okay.
Sir, if the length of the line is more bigger, from where should be taken, sir, or 2, something like that?
Okay, so this is more. Okay. So from 1
Yes,
if I
sir.
take, it is going beyond. Okay.
Yes, sir.
So when it is going beyond, I have to move back. 2 is
Okay.
coming in the range. Even at 2, if it
Yes,
is
sir.
going out, then I have to move
Yes.
again to 3. Okay.
Okay, sir. Okay,
So
sir.
that way we have to
Mic
do it.
testing, mic testing.
Oh, someone is testing mic. Don't do all this stuff, okay? It disturbs the class. So Sai Teja, mute yourself back if your doubt is clear and lower your hands. Put down your hands. Rahul, any doubt?
Sir, I have a doubt, sir.
Yes?
Why did you take 0.07, sir? 0.1 into 7.
Because we are going up now. So when we go up, what happens is, let me show you. When we go up, so distance from this point to this point. Are you getting it? It's a very, very small distance.
Yes, sir.
Okay. So this distance, how much is this distance?
0.25.
0.01 meters.
0.1.
Okay. So when we go two of them, when we go for two distances from here to here, we get how much? 0.02.
0.02.
So we went up for how many divisions? We went up for 7 divisions, right?
7 divisions, sir.
And hence we have to take 0.07.
Okay, sir. Okay.
Okay, so put down your hands if your doubts are clear and mute yourself back. Jayant, please put down your hand. Okay, fine, good, very good. So next is comparative scale. Comparative scale consists of same scale value. So the ratio that we are taking will be remaining same, but the units will be different. Fine. So in the above scale, if you see, this is a plane scale. Okay? And in the plane scale, what is the unit we are using? What is the unit in the plane scale?
Meters.
It's
Meters.
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 It's meters. Very good. But below you can see what type of scale is this?
Yards.
Yards, feet, inches.
It's a diagonal scale. Okay? So in the diagonal
Diagonals.
scale, what is the unit we are using?
Yards, sir.
Yards,
Yeah.
feet, and inches.
Feet and inches.
Okay, very good. So we can compare the two scales. Fine. So if you want to convert 4.7, you can see here 4.7 I have measured on the plane scale, and I had to convert it into yards, feet, and inches. So 4.7 meters is equal to 5 yards, 0 feet, and 4 inches. Okay. So like this, you can convert one unit into another using comparative scales. Okay. Yes, Jayant.
Sir, one box is equal to 1 yard, sir.
Actually, 3 feet are equal to 1 yard. 3 feet are equal to 1 yard, and 1 feet has how many inches? 1 feet has how many inches?
12
inches.
12 inches.
12
Very good.
inches.
12 inches. Very good. And 1 inch is equal to 2.56 centimeters. Fine. So using these conversion things, first we have to create the scale, and once the scale is ready, we can convert. So we can convert the scales like that. Okay. And the last scale, this scale was very helpful to students when they did manual drafting. Fine. So we all know there is a scale called, some people call this D scale, especially in Hyderabad. Okay. So what is this?
Protractor, sir, protractor.
Protractors, sir.
Yeah.
Protractor,
Protractor. And what is the use of a protractor?
To
protractor.
measure angles.
Angle.
For measuring angles. Very
Measure
good.
the angles.
Angles, sir. All angles.
Okay. Okay.
To know
Okay. Very
exact
good. Very
degree
good.
of an
Thank you.
angle.
So now, suppose you are going for the exam and you forgot to take protractor with you. Then what will you do? You cannot ask someone else the scale. So in such cases, this scale came to your help. So you can create your own protractor. And that protractor, it doesn't look like a protractor. It looks like this. Fine. So this is called a scale of chords. This is called a scale of chords, and this scale of chords can be created by you directly, and this can be used to draw whatever angle you want to draw. Okay. So we will not go into the details how to do it. It will take a lot of time. Okay. So I will explain it later when this topic comes up during our regular class. Okay. So these are all the scales. These are all the scales that we will be learning. Okay. So this is a part of the first unit. This is a part of the first unit. After scales, we'll have to take up some curves. We'll have to take up some curves. So the first curve that we will take up will be called as involute. Fine. So does anyone know about involute? Has anyone heard involute anywhere?
No, sir.
No.
Okay. So involute is used in the name of gears. Okay. So there are some gears known as involute gears. Okay. And in involute gears, the speciality is that even if the distance between the two gears are changing, still there won't be any problem with the meshing gears. Okay. So when the two gears, when they are meshing properly, if the distance between the gears changes, then there will be a problem with transmission of the power. Okay. But with involute gears, there won't be any such problem. Fine. So that's the speciality about the involute gears. So
Sir,
here
I can hear some phone ringing, sir.
yeah. So that's some phone ringing in the staff room. It's off now. Okay. Fine. So we have to draw various involutes. So here you can see an involute of a straight line. So I've taken a straight line and I've drawn the involute for that. Then here you can see there is a triangle. Okay. There is a triangle and then we have drawn the involute. Then what is here? We have a square. Okay. We have a square and we have drawn the involute. So like that, we have to take various cross sections. Depending on the question, we'll have to take up various cross sections and we have to draw the involute curve. Okay. Finally, we have to draw the involute of a circle. And this involute is what is used to create the gear. So let me show you how that's done. Okay. So this is one teeth of the gear. Okay. And now you can see. So is this a gear? This is a gear, right? This is how the gear looks.
Yes, sir.
And we can take two gears.
Yes, sir.
And we can mesh them properly with each other. Okay, so when the teeth are meshing properly, that will transmit motion from one gear to the other gear. Correct? So this is what is the involute. So you have to create involute for one full unwinding. Okay. So these are all the involutes. After involutes, we will have to take up cycloids. We have to take up cycloids. Fine. So the cycloid looks like this. Fine. So what happens in cycloid is we have a straight line. And there is a circle which is rolling on that without slipping. Okay, there is a circle which is rolling on that without slipping. Okay, so here you can see this is a circle. So hope the video is clear to everyone. So this is a circle, and when it rolls without slipping on a plain line, fine. And if you are taking the pen, fixing it on that and rolling it, fine. So the curve that it follows, that is called as the cycloid. So this here you can see this is the path by the circle. That's a cycloid. And if the path is not a straight line, instead of straight line, if the path is curve, then this is called epicycloid. This is called epicycloid. Fine. The circle is rolling outside the circle, another circle. Then the curve that we get is called as epicycloid. Epi means outside. Okay. Please mute yourself. Please mute yourself. There is some disturbance coming. Some disturbance is coming. Please mute yourself. Okay. Fine. So next, suppose there is a circle which is rolling inside another circle. If the circle is rolling inside another circle, then it is called as hypocycloid. Then it is called as hypocycloid. Hypo means inside and epi means outside. Okay. So these are the three cycloids that we have to learn. Now, depending on where we are taking the starting points, there are various questions that can be asked. Like here, the diameter of circles, both the rolling circle and the base circle, both the radii, they are equal. In that case, we get heart-shaped curve like this. Okay. So, one simple question here. Has anyone seen this heart-shaped shadow anywhere? Anyone has seen this shading anywhere? In
No,
real
sir.
life?
No,
Can,
sir.
sir.
People who drink coffee, they will be aware of this. Yes. So when you take
Cappuccino.
cappuccino or no cappuccino, they'll put the powder in that shape and then that will take shape. That's not what I'm talking about. So when you take coffee in your cup and if the light is coming from some direction, then you will get a heart-shaped shadow in that. Okay? So that shape is epicycloid itself. Okay? So anyway, we will learn more about that when we take up that problem. Okay? So these are all cycloids. Next, we will have to take up conics. Anyone knows what is a conic? I think in intermediate you have learnt about this.
Yes, sir. Yes, sir.
Yes,
How many
sir.
conics are there?
Hyperbola, ellipse, hyperbola,
Ellipse,
parabola,
parabola,
There's one more.
circle.
Circle. Very good.
circle.
Very good. Very good. So when you take a cone and cut it straight, that's when we get a circle. Correct?
Yes, sir.
Yes.
Yes.
Yes, sir.
Then if you are cutting it parallel to the slant edge, we get a parabola.
Yes, sir.
Second, and if it is touching
Yes.
both the slant edges, then we get
Ellipse.
ellipse. Okay. And if it is touching only one edge, that's when we get
Hyperbola.
okay. So all these curves, you should know how to create them. So there will be a lot of steps. Fine. So first you have to draw a rectangle, then divide into equal number of parts, then draw some construction lines, then take the intersection of some particular lines, and then you have to join all these lines using a smooth line. It's called a spline in AutoCAD. Okay? So all these we will have to learn. Okay? So there are a lot of different methods used for drawing it. For example, sorry, what you see here on the screen is the general method or the eccentricity method. Okay?
Yes.
Do you know what is the eccentricity of a parabola? What is the
2e by
eccentricity of a parabola?
1.
It's 1. Very good. Yeah, and for ellipse, how much is the eccentricity?
More than 1.
it is
Less
more
than
than
1.
1.
Less than 1.
Ellipse
Yes,
is
sir.
less
Less
than
than
1.
1.
Okay. And for hyperbola?
More than 1.
Greater than 1.
Greater than 1.
More than 1. Okay, very good.
Greater than 1.
Yeah. So no, this is how the curves look like when we put them overlapping with each other. Okay. So ellipse has the shortest eccentricity, so its vertex point will be nearest to the focus. Okay.
Yes, sir.
And then comes the parabola. Parabola is equidistant from the directrix as well as focus. From both, it is at same distance. Whereas a hyperbola is nearer to the directrix and a little far away from the focus. Okay.
Yes.
So we'll have to learn how to create all these curves. Okay. So you can see there are a lot of problems from previous papers that I have solved here. All these step by step you people have to learn. Okay. Fine. So this covers. So this total thing, it covers your first unit. So your first unit has scales and all the curves in it. Okay, scales and curves. This is what we have in the first unit. Then let's go ahead and see what we have next. So next, we have something called orthographic projections. Fine. What is ortho? Anyone knows what is ortho? Ortho means
90 degrees.
90 degrees. Very good. Ortho means 90 degrees or perpendicular. So
Perpendicular.
what happens is we have planes like this. Fine. So this plane here is called VP. VP means VP means
Vertical plane. Vertical plane.
vertical plane.
Vertical.
Vertical plane. Okay. VP means vertical plane. And what is HP?
Horizontal.
Horizontal plane.
Horizontal.
Horizontal.
Plane. Very good. So we have a vertical plane and a horizontal plane. And what is the angle between them?
90 degrees.
90 degrees.
90 degrees.
Very good. Very good. The angle between them is 90 degrees. And also, if you are projecting a point, fine, if you are projecting a point. So let us say here we have a point A. Here we have a point A. So this point A is above HP. Where is A? A is
Above which.
and in front of VP. Okay. Yeah. So we have to take its projections on HP and VP. We have to take its projections on HP and VP. What is projection? Projection is like a shadow. Projection is like a shadow. Okay.
Shadow.
So let us say this is a sphere. This is a ball shape here. So when you look at it from this direction, what we get? We get a circle. Okay? So a ball looks like a circle from any direction. So this shadow of the point A on VP, what is it called? Which view is this?
Vertical plane.
It is on the vertical plane.
So,
And yeah, someone
So
is giving me
disturbance,
Lot of
disturbance.
disturbance.
please mute yourself. And when we take its projections on the HP, what do we get?
Top view.
We get
Top
view. Very good. So we always get the top view on HP. We get the top view on HP, and we get the front view on
VP.
very good. Yeah. So now you can see that these planes, they are at 90 degrees to each other, and they are in 3 dimensions. Correct. They are in 3 dimensions. We cannot draw it on the drawing sheet. Our drawing sheet is 2-dimensional, correct? So how to draw this 3-dimensional object on the 2-dimensional sheet? Fine. So that's where what we do is we rotate this plane. What do? We rotate the HP. Yeah, we rotate the HP and we make it coplanar with the VP. We make it coplanar with the VP. And this line is the center line. It's called as XY line. Fine. So when you draw the orthographic view of the point, this is how it will look. Okay. So you don't have to draw all this. This I have drawn just to explain to you how it happens. Okay. You will not have to draw all this. You just have to draw this type of diagrams. These are much simpler, right? So above XY line is VP, and this is where we are getting the front view. And below XY line is HP, and this is where we get top view. Okay. Is my voice clear?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay. So the screen there is a bit of lag in the screen. Depending on your internet connection, that lag may be more or less. Fine. Anyway, the recording is happening. So when it is recorded, I'll post it to you. So no worries about that. So we just have 10 minutes. Fine. So I'll just fastly go through what all are the other things that we have to do. So this is called projection of points. We are just taking points and we are projecting them. After points, we'll have to take up lines. So you can see here, there is a line CD and we are drawing the projections of that. Okay. So the line CD, front view looks like this. Top view appears just like a dot. Now when the line is inclined, then we get other type of problems. Okay. So you can see here that the line is inclined to both the planes. So when it is inclined, when the line is inclined, its true length will not appear in any of the views. Its true length will not appear in any of the views. Fine. And there is some procedure to draw its true length and then convert it into the final view. Fine. So we will learn all about that. And there are a lot of problems. There are a lot of problems that may be asked. Yeah. So we will learn about these problems as well in the coming classes. Okay. After lines, we have to take up planes. What is a plane? A plane has area but no thickness. Okay. A plane has area but no thickness. So we can have a square plane, rectangular plane, hexagonal plane, circular plane. Fine. So all kinds of planes we can have. So when you keep the plane at some angle, and then we have to take its projections on the front view and on the top view. So we'll have to draw such problems, solve such problems. Sorry. So you can see there are a lot of problems, a lot of different problems are there. So one of these problems I will be covering in the class, and then for the rest of them, I'll be posting the video. Okay. I'll be posting the video. You can watch the video, learn how to do it. Okay. You may have to install AutoCAD on your system at home and to practice that. I have a video explaining how you can download that as well. I will be posting it to your WhatsApp group later. Okay. So once we are done with the planes, what is more complicated than a plane? Solid. Okay. So these are all solids. So we will be learning to project some right regular solids. Right regular solids. So there are overall two types, or to say 4 types of solids that we should learn to project. The first type are the prisms. Fine. The second types are pyramids. So everyone knows the pyramid, right? Everyone knows the pyramid. So you have seen the
Yes,
mummy,
sir.
yeah, pyramids of
Yes,
Egypt.
sir.
So pyramid of Egypt is basically a square pyramid. Fine. So the base of the pyramid will be in the shape of a square, and there will be a top single vertex point. Fine, where all the
Yes.
where the vertex will join all the base vertexes. So we can have a pentagonal pyramid. We can have a triangular pyramid. Even you see a tetrahedron. You must have heard about tetrahedron.
Yes, sir.
So a tetrahedron is also a pyramid. What kind of pyramid is it? It's a triangular pyramid. The base
Triangular
of the
pyramid.
tetrahedron is a triangle. Base of a tetrahedron is a triangle, and there is a single vertex at the top. Fine.
Yes, sir.
So this is a tetrahedron. You can see this is the mummy pyramid. Fine. Actually, the height is much more in this case. Fine. So the pyramids of Egypt have much lower height. Anyway, then here you can see this is a pentagonal prism. Pentagonal prism. Then this is a cube. What is a cube? A cube is also a pyramid or prism?
Pyramid.
No, it's not a pyramid. It's a prism.
No idea.
It's a prism. You can see the prism has same cross section from top to bottom. The prism has same cross section from top to bottom. So when you cut a prism anywhere parallel to the base, we get the same cross section. But in pyramid, at different heights, we have different sizes. The size reduces as we come from bottom to the top. Okay, that's how you can identify a pyramid from a prism. So this is a prism. It's a prism with square cross section. It's a prism with square cross section. Same way here, you can see this is a triangular prism. And this triangular prism you must have used in the physics lab, if I'm not wrong.
Yes, sir.
So it breaks the sunlight, white sunlight, into Vibgyor or rainbow.
Yes, sir.
Rainbow.
This is that prism. So there are various problems possible with this also. Okay? So you can give different heights, different base edges, different inclinations with HP and VP, and based on that you'll have to find the final projection of the problem. After the solids, we'll have to cut open the solids. Fine. So we have to cut the solids at different angles, and then we have to show what the view looks like. Okay? Sometimes we have to create the true shape of the section, sometimes the sectional view, sometimes the sectional top view, and all such things. Okay? So this is all sectional views, section of solids, that's what it is called. After that, we have intersection of solids. What is intersection of solids? When two solids are intersecting, interpenetrating, you can say. When two solids are penetrating, one solid is going inside another solid. That's when we get intersection of solids. Fine. So when the two solids, like here, you can see there are two cylinders going inside each other. There is one cylinder vertical and one cylinder horizontal. So when they are interpenetrating, at some point, you can see some edge there, correct? You can see there will be some edge. So that edge you should learn how to create. Okay, that edge you should learn how to create. Fine. So this is intersection of solids. Again, there are a lot of different types of problems. We will learn a few of them. Then we have something called development. Fine. In development, what happens is you will have to take the solid and cut it open. Fine. You have to take the solid and cut it open. Fine. So when you open it, you will get the shape of the sheet. You will get the shape of the sheet. And once you fold that sheet back, you will get back the solid. You will get back the solid. So that's what we do here in development. Okay, that's what we do here in development. So once again, we will be taking up right regular solids. We will be taking up prisms, pyramids, cylinders, and cones. Prisms, pyramids, cylinders, and cones. And then we will be cutting them at different angles, and we will have to develop into the shape of the sheet. So you can see there are various problems, various different kind of problems have appeared in the previous exams. We'll take up a few of them in our class. And I think this is the last topic. The last topic what we have to do is we will have to take a machine component, a complicated machine component, and then we'll have to create its front view, top view, and side view. Okay, front view, top view, and side view. We'll have to generate from the given 3D diagram. From the given 3D diagram. Fine. And same way, some cases we will be given 2D diagram. Fine. We will be given the front view and top view. Using that, we have to create the isometric diagram. So this 3D diagram is called isometric diagram. Okay. So both ways we may have to do. So if you are given the front view, top view, you will have to convert it into 3D diagram. If you are given the 3D diagram, you will have to convert it into the front view, top view. Okay. So this is your complete syllabus. Fine. I hope you have understood what the complete syllabus is and what we will be learning in the coming classes. Fine. So any doubt at this point?
Sir, this all syllabus we are going to learn in computer, sir.
Yes, we'll have to do it in computer itself. There is a small,
Sir, no pen and paper required, sir. Only
yes, no?
files and projects.
Yes.
Computer.
Files. On the computer, you'll have to
Only
do it.
in
And
system.
I will tell you how to convert your diagram into a PDF file. And that PDF file, you have to upload it on the Teams.
Okay, sir. Sir, otherwise we have to log in with the student version.
Yes. Student version you have to download on your system, install it. On that itself, you have to solve all the problems. Okay?
Okay, sir.
Sir, then in exam, how we will go?
Exams
In
also, you will have
exam.
to do it on system only. You'll have to we will provide you some questions. You have to solve it in the software, take a printout of that, attach it with your answer script and submit. That's how the exams will go.
Okay, sir.
Yes, sir.
Any other doubt?
Sir, when question, sir?
Just give me 1 minute. I'll download the attendance. I'll just download the attendance.